Hi guys, this is Mrs. Denton coming with lesson 4.4, comparing linear and nonlinear functions. Grab your notebook paper, label it, and let's take some notes and work out some problems to compare linear and nonlinear functions. Okay, we've got some vocab. Sorry, bumped the wrong spot there. A non-linear function does not have a constant rate of change. Now, when we say constant rate of change, it means it's consistently staying the same as we move throughout each ordered pair or relation. The graph of a non-linear function is not a line. So, non-linear, not a line. Linear forms a line. Okay, and remember, you can pause the video at any time if you need to go back and review or write anything else in your notes. Okay, example 1 says, does the table represent a linear or nonlinear function, and explain? So we're looking at table A. And this time our table is horizontal rather than vertical, but we can still go through the same pattern to see the rate of change. So with my input or x value, I'm going from 3 to 6, which is an increase of 3. The next one goes from 6 to 9, which is another increase of 3. And the next one, again, increasing by 3 each time. Now I'm going to look at my output, or my y value, and I can see that y in this first situation is decreasing by 8. The next one is also decreasing by 8. And here in this last one, we have a difference of 8 as well. So when it says explain, we can simply say as x, or our input, increases by 3 because it's going up by 3, y decreases by 8. The rate of change is constant. So the function is linear. So if the rate of change is constant, the function is linear. That means it's going to be creating a straight line. Okay, we're going to do the same thing with B. Example B. So let's look at our input or our x value first. We've got an increase of 2, 2 again, and 2 one more time. Now when we look at our output, we have an increase of 9 with 2 and 11. With 11 and 33, we have an increase of 22. And with 33 and 88, we have an increase of 55. So if I were to compare the rate of change, or slope, and I thought about it like y compared to x, each one of these comparisons would be different. So that tells me the rate of change is not constant. So this isn't going to form a line, it's actually going to be nonlinear. So we're going to explain that. As x increases by 2, y decreases, let me change that. y isn't decreasing. Not sure why I said that. Y increases by, and look up there at your differences. It's different amounts each time, so we're just going to make note of that. And we're going to say the rate of change is not constant. So the function is non-linear. If we were to graph those ordered pair, it would not be a line. Okay, example 2. Now we're actually going to look at graphs to determine whether they represent a linear or nonlinear function and explain. Now this is pretty simple when you look at a graph because obviously you can tell if it's a line or not a line. The part that we're going to explain is simple as well. So looking at example A, we can see this graph is not a line, so the function would be non-linear. And that's all we have to explain. The graph is not a line, so the function is non-linear. Now, when we look at example B, we can see that this graph is a line. We have a horizontal line there. In example A, we had curve to that line. So example B, we're just simply going to say the graph is a line. So the function is linear. Okay, now we've got 3 problems to look at on your own. If you will pause the video and look at each 3 of these, go through those same processes that we did in example 1 and 2. Write some things down, look at the changes in x and y in number 1 and number 2, and decide if they would be linear or nonlinear. In number 3, you simply just have to look at the graph to decide. So go ahead and pause and take some time to decide on these, and then when you unpause the video, we will look to see if you got those correct. Okay, let's talk about number 1. With our input value in this first set from 0 to 7, we have an increase of 7, another increase of 7, and a third increase of 7. With our y, or output, we have a decrease of 5, another decrease of 5, and another decrease of 5. So, does the table or graph represent a linear or nonlinear function, and explain? We can say this is linear, and our explanation can be as x increases by 7, y decreases by 5. Okay, looking at number 2, with our input or our x value, we can see an increase of 2, another increase of 2, and yet another increase of 2. With our y value, we have a decrease of 4, another decrease of 4, and another decrease of 4. We're finding the difference between these values. So we can see that the rate of change is constant. So let's try that as an explanation. So number 2 is linear. The rate of change is constant. Now remember, another name for rate of change is slope. Okay, and number 3, I can simply look at the line, and I can simply look at the graph and tell that that is nonlinear. The graph is not a line. So our explanation for number 3 is simply going to be, and then I go and start writing the wrong thing, sorry. So our explanation is nonlinear. And we can say the graph is not a line. Okay, now let's talk about equations. So example 3 says, which equation represents a non-linear function? Now, if you will recall, we can graph a linear function with the equation y equals mx plus b. So slope-intercept form. So if that works for linear, then we can look at these equations and determine if they can be rewritten in slope-intercept form. So that's basically how we're going to judge whether it's linear or nonlinear. Let's look at A. Y equals 4 7/10. So when we're graphing a linear function and we have an equation like y equals 4 7/10, if you will recall, that is a horizontal line. So it is technically linear. So A is okay. Let's look at B. B is in the form y equals pi x. Okay, so I can rewrite that equation in slope-intercept form. I could even graph that equation and it would still create a line. So the equation in B is still okay. Let's look at C. Now C has y equals 4 divided by x. If I'm not really sure about that, I can attempt to rewrite that in slope-intercept form, which I might want to try moving x. So I get rid of it on this side, I move it to the other side, I end up with x times y equals 4. I'm trying to get y by itself, and I'm just going to go back to the original form that I had earlier. So that's the only progress that I've made, is going back to the original form. So C cannot be written in slope-intercept form. So we're going to mark that one. And let's go ahead and check out D to make sure that's the only choice that's correct. So in D, I have y equals 4 multiplied by x subtract 1. If I go ahead and distribute that 4, I get a new equation that looks like y equals 4x subtract 4, which is exactly written in slope-intercept form. So that would still create a line. So which equation represents a nonlinear function? Right over here at C. We cannot rewrite it in slope-intercept form. Okay, let's look at these 3 examples. Pause the video if you can and look and see what you have as far as the equations being linear or nonlinear. Okay, I'm going to go ahead and work through these. So let's talk about number 4. Remember, linear is slope-intercept form. Nonlinear cannot be written in slope-intercept form. So if I'm looking at number 4, automatically I see I would have a slope of 1 and I would have a y-intercept or b of 5. So that is already in slope-intercept form. So number 4 is linear. And my explanation would be the equation is in slope-intercept form. Okay, let's look at this number 5, the middle one. Y equals 4x divided by 3. Now, on number 5, I'm looking to see what I can move around. If I were to move or attempt to get this in slope-intercept form, there's really not much I need to do other than think about 4/3 separate from x. So if I just simply wrote my 4/3 as my slope and put x beside it, then I have it in slope-intercept form just like that. So we can say number 5 is also linear. You can rewrite in slope-intercept form. Okay, let's look at number 6. I'm trying to get this in slope-intercept form. I'm looking at y equals 1 subtract x squared. This subtract x squared is not going to allow me to put anything in this equation in slope-intercept form. So this automatically becomes nonlinear. You cannot rewrite in slope-intercept form. If I try to undo the squaring, I'm going to have the square root, and I'm still not going to be able to get rid of that factor. Okay, the next part that we're going to talk about is a vertical line test, and we talked about this a little last week. You can use a vertical line test, to determine whether a graph represents a function. And that just simply says a graph represents a function when no vertical line passes through more than one point on the graph. The example on the left, you have that one point. The example on the right, you have multiple points. So that's called the vertical line test. You can use your pencil and you can go from left to right to see if that passes the vertical line test. If it does, then it is a function. If it doesn't, it is not a function. Okay, example 4 says determine whether each graph represents a function. So think about this like a vertical line test. And you can visually see in example A, right here, I'm drawing multiple lines, trying to get used to a new stylus. So let's look at it again. Let me see if I can make a better line here. Well, maybe. Okay, so if I were to make a straight line, I still didn't make a straight line, but if I made lines through those, you can see there's multiple points where those values are shared. So looking at example A, we're going to state that we could draw a vertical line through this point here at 2, 2, this point here at 2, 5. We have some points over here that are in common as well. So we're going to say this graph does not represent a function. The graph does not represent a function. Okay, looking at B, if I take my vertical line and I go from left to right, I can think about as many vertical lines as I want, but they all have just one point where it crosses. So no vertical line can be drawn through 2 points on the graph. Therefore, this graph represents a function. So we're going to say this graph represents a function. Okay, look at 7, 8, and 9 and think about passing a vertical line from left to right of the graph and decide if you think that passes the vertical line test. If it does, then it is a function. So looking at number 7, no vertical line could be drawn through 2 or more points on the graph, so we have a function. Number 8, it appears to be the same thing. There's no way I could cross. If I tried to make some vertical lines here, they're only going to cross that point at one spot. So we have another function. And in the last one, if I were to think of a vertical line, I'd have a point there and a point there where it crosses, just that first vertical line. So we have not a function in number 9.